Today, we're going to talk about a secret toolkit that can totally change the way you write code. We're diving into software design patterns. And trust me, once you get these, they're an absolute game changer for building software that's elegant, tough, and most importantly, easy to work with.
You know the feeling, right? We have all been there. You're working on a project, you add what seems like a totally harmless new feature, and then boom. Suddenly, other parts of the app just start breaking. It's so frustrating, and it's usually a sign that there's a deeper problem with how our code is put together.
So, where does that mess even come from?
Well, it almost always starts simple. You have a great idea, a clean project, but then it grows. Let's walk through a little story that's probably going to sound, well, pretty familiar.
Okay, picture this. You've built this amazing navigation app. Version 1 is a total success. It just builds routes for cars. The code is clean, it's elegant, it just works. Life is pretty good, but, success brings new requests. First, users want walking directions. Okay, then they want public transit, then routes for cyclists. And with every single new feature, you find yourself just stuffing more and more and more logic into that main navigation class. And before you know it, your once beautiful code is just this bloated beast. It's a tangled web of if-else statements. Trying to fix one tiny bug feels like you're defusing a bomb. And working with a team, forget about it. It's just a constant, painful stream of merge conflicts. This is a sure sign we need a better way to think about our code. Thankfully, and this is the good news, we don't have to just live with that chaos. We don't have to reinvent the wheel every single time we face this problem. The answer lies in using proven solutions, kind of like blueprints, that are designed for these exact situations. We're talking about design patterns. So what is a design pattern really? Well, it's not a library you can just download, and it's not a finished snippet of code you can copy-paste. Think of it more like a recipe or a blueprint. It's a general, well-tested way to solve a problem that developers see over and over and over again. It's a concept that you can shape to fit your exact problem. But here's the kicker. Patterns aren't just about writing code. They're about communicating with other humans. They create a shared vocabulary, a shorthand for complex ideas. When your whole team speaks this language, you can design and solve problems together so much faster. And this idea has a pretty cool history. It actually didn't even start with software. Way back in 1977, an architect named Christopher Alexander was writing about patterns for designing towns and buildings. Then, in 1994, 4 software engineers, who we now call the Gang of Four, took that idea and applied it to programming. Their book became an absolute legend, and today, these patterns are a basic building block of good software design. So these patterns are usually sorted into 3 main groups. You've got creational patterns, which are all about how we make objects. Then there's structural patterns, which focus on how we assemble objects together. And finally, behavioral patterns, which deal with how different objects talk to each other. So let's take a quick look at one key example from each of these categories.
First up, let's talk about creational patterns. The whole point of these is to give you more flexible ways to create objects so you can reuse code instead of rewriting it.
A really classic example here is the factory method. It's kind of like setting up a factory for making your objects. Your main class knows it needs a product, but it doesn't create it directly. Instead, it calls on its subclasses to actually do the manufacturing, and they get to decide the specific type of product that gets made. Let's make that real. Say you're building a user interface that has to work on both Windows and on the web. Instead of having a bunch of messy if-else logic in your main code to check the operating system, you use a factory method. A Windows dialog class makes a Windows button. A web dialog class makes an HTML button. And the best part? Your main application code doesn't care. It just asks for a button, and the factory handles the rest. It's completely decoupled.
All right, next up, structural patterns.
These are all about how we compose objects and classes into bigger structures without making everything rigid and hard to change.
The adapter pattern is a perfect example of this. It's so intuitive. It basically acts as a translator or a go-between that lets two objects with totally different interfaces work together like they were made for each other.
The real-world analogy here is just perfect. It's a travel power adapter. You're in Germany, you have a US plug, you can't just rewire the wall, and you're not going to change your laptop's charging port. So what do? You use an adapter. It's this simple thing that sits in the middle and makes the two incompatible things compatible. The adapter pattern does that exact same job for your objects in code. And last but not least, we have behavioral patterns. These are all about making sure our objects can communicate and work together effectively without getting into a tangled mess. Now, the strategy pattern is, well, it's incredibly useful. It lets you take a bunch of different algorithms or ways of doing something, and you wrap each one up in its own little class. Then you can swap those classes in and out on the fly. You can change how something is done without changing the part of the code that's asking for it to be done. Okay, remember our poor navigation app, the bloated beast from the beginning? The strategy pattern is its savior. Instead of one giant, nightmarish if-else block, you create separate strategy classes. A car strategy, a walking strategy, a transit strategy. The main navigator just holds on to the current strategy and says, hey, build me a route. Want to add bike paths now? Easy. Just create a new cycling strategy class. No changes to the main navigator are needed. It's clean, it's simple, it's beautiful. So, what's the big takeaway here? Why should you care? Because learning these patterns isn't just some boring academic exercise. It's like unlocking a new superpower as a developer.
So let's just boil it down. Patterns help you stop tying your classes into a giant tangled knot, which makes your whole system way more flexible. They let you add new things without having to rip apart old code. This is called the open/closed principle. And maybe most importantly, you get this shared language to talk about design with your teammates.
And this is the real magic of that shared language. Instead of a 10-minute confusing explanation about how you want to structure something, you can just say, oh, let's use a singleton for that, or the strategy pattern would be perfect here. And just like that, everyone on the team gets it. They understand the entire structure you're proposing. It's incredibly efficient. So I'll leave you with a question to think about. Take a look at a project you're working on right now. I guarantee if you look close enough, you'll find some tangled logic, a bloated class, some messy communication that could be solved elegantly with one of these patterns. Thanks for joining me.